And this row is all zeros. And so this meets my criteria for being reduced. Every row either has a leading one or all zeros. Now, how do I interpret the answer? Well, to find out about the arbitrary parameters, all I need to do is look at the columns. Remember that an arbitrary parameter is a variable whose column does not have a leading one in it. So I'm looking for columns that don't have leading ones for my arbitrary parameters. So which guys are those ones? Well, where do I not have a leading one? In this first column, I have a leading one. It's right there. So x, this is the x column, is not an arbitrary variable, not an arbitrary parameter. But no other column has a leading one. So each of these are missing a leading one. So these are all arbitrary parameters. The variables for those columns are arbitrary parameters. That's y, z, and w. Those are all arbitrary parameters. So y, z, and w are arbitrary. Okay. So that's important for us to know. I have 3 arbitrary parameters. And whenever there is at least one arbitrary parameter, that means that there are infinitely many solutions. And to represent those infinitely many solutions, I'm going to basically take this equation from the first row and solve it so that all the arbitrary parameters are on one side and the non-arbitrary guys are on the other side. So x is my only non-arbitrary thing, so I basically want to solve the equation for x. So let me make this really explicit. Write down the equation that I get from this first row. I get x plus 3y plus z minus 3w equals 4. That's just reading off this first row as an equation. Now, to represent all of my solutions, what I'm basically going to do is just get x by itself in this equation. So I'm just going to subtract these other terms to the other side. So my sort of general solution is maybe the term I've been using, is going to look like this. X equals, I subtract over 3y, I get negative 3y minus z plus 3w plus 4. So notice I've moved all of the arbitrary variables to one side, and I kept the non-arbitrary thing on the other side. Okay. And the reason we call this a general solution is that since y, z, and w are arbitrary, that means I can pick any numbers I want for those. But once I pick those, that tells me what x has to be because of this equation. Yeah. So if I pick 1, 0, 0 for y, z, w, then I get 1 here, 0, 0. So that's negative 3 plus 4, so x would have to be 1, for example. So it determines x. So the point of the arbitrary parameters are that they're arbitrary, so I could pick any number for them. And once I pick the numbers for them, they then determine the non-arbitrary variables. They tell me what they have to be. So, okay. So sorry that was a little scattered, and I also knocked over my camera. But did that answer your question, or do you guys have more questions?
I have a quick question about this.
Yes.
Let's say that we had like, if we were dealing with something with more than 2 rows, if we had like more than one number that was not a 0 or a leading one, but within the same column, does that affect the number of arbitrary parameters or no?
Let's see. Let's see if I can, I'm not sure I fully understand your question yet. Could you say that again?
Yeah, so like, let's say in the y column, for example, we had like a negative 3, but then also further down in another row, but within the same column, we had like a 2.
Okay.
And would that ever happen in a fully reduced matrix where we had like more than one, but within the same column?
So what I would say is, here's an example of a reduced matrix. I'll give you. Maybe this will answer your question. I don't know. This will work. 0. Not a reduced matrix yet, actually. So this one's actually not reduced, and the reason being, so you kind of wanted these extra numbers here in this column. So maybe this is a bad example, but I guess I'll just talk through this. This is not reduced because I have a leading one here, but I'm missing a leading one in these other rows. Yeah. And so I need leading ones in every row. And so maybe this is just a bad example for your question, or maybe I'm just not understanding your question entirely. Maybe here's a better example. Here's another matrix. This one is reduced. So here's not reduced. This one is reduced. And maybe something you're getting at is like having this extra junk up above the leading one. Oh, hang on, not man. All right. Sorry, guys. I don't know what's going on with me today. Okay. Now it's reduced. Yeah, remember, leading ones need to be the only, so one thing to say is that a leading one is the only non-zero thing in its column. Yeah. So this is reduced now because I have leading ones in these rows, and this last row is all zeros. But where I don't, if I have a column which is missing a leading one, there could basically be anything in it. You know, this column here doesn't have a leading one. So it doesn't really matter what goes on up here above the zeros. It can just be a bunch of junk. It could be any numbers. And the only thing that'll change is the equations that you will get. So
sure. But let's say we had this reduced matrix here, and there was a question asking how many arbitrary parameters are there? The answer is 1, correct?
Yes.
Okay. So even though there are multiple numbers that are not 0 or 1, since they're all within one column, that means there's one arbitrary parameter.
Ah, yes. Yes. Okay. So now I understand exactly what you mean. And yes, I'm only counting the columns where I'm missing a leading one. That's how many arbitrary parameters there are. And so there's just one column missing a leading one. So this gives me one arbitrary parameter only. It doesn't matter what these numbers are at all. Okay. That's a good question. Sorry, that was a little convoluted. Okay, any other questions?
Could you do number 36?
36, let me take a look. Okay. So let's see, we have x minus z equals 2. We have 2x minus y minus z equals 3. And we have 2y minus 3z is 4. Okay. So I have this system of 3 equations, and we're asked to solve it. We have to find all solutions. And so we're going to go ahead and do this with a matrix again. And I just need to write down the matrix and try to solve it out and then see what happens. So let's write down the matrix. The first row is, so I have 3 variables. I have x, y, and z. This first equation is missing a y. But when I don't have a y, what that really means is that the coefficient of y is 0. So in the y column, for the first row, I'm going to put a 0. So I would read this first equation as 1, 0, negative 1, 2. That would be my first equation in the first row. Okay. The second row would then be 2, negative 1, 3. And the last row, I'm missing an x, so I'm going to put a 0 in the x part. So it'll be 0, 2, negative 3, 4. All right. So this is my matrix, my augmented matrix. I now need to try and reduce it. So we might notice the first step is to get a 1 up here. There's already a 1, so I don't have to worry about that. So the next thing I need to do is make a 0 and make zeros in its column. So I need to turn this 2 into a 0. So to cancel out 2, I want -2. So let's multiply the first row by -2 and add that to the second row. So we'll take row 2 plus -2, row 1. Okay. So what happens? Well, 2 plus -2 is 0. -1 plus, well, -1 plus 0, which is -1. -2 plus times -1 is +2, so I get -1 plus 2, which is 1. And then -2 times 2 is -4, so 3 plus -4 is -1. And then I didn't change anything else. So there's my new matrix. I am now done with the first column because I have a 1 and then 2 zeros. So now I want to move on to the next row, next column. And now I want a leading 1 here if I can get it. I have -1. So let's change that to +1. Let's just multiply the second row by -1. Just to turn that into a +1. So that's what I'm going to get. And I'll go up here. Okay. So let me just rewrite this matrix up here so it'll be a little clearer on the board what I'm doing. Okay. So I have this matrix after these two operations. And now my next goal is let's get a 0 where this 2 is. Yeah. I want this to be a leading 1, which means it needs to be the only non-zero thing in its column. So I need to get a 0 where this 2 is. So again, to cancel 2, I'm just going to take -2 times the second row and add it to the third row. So we'll take row 3 plus -2, row 2. So what happens? 0 plus 0 is 0. 2 plus -2 will be 0. -2 times -1 is +2. -3 plus +2 is -1. And 4 plus -2 will be 2. And then I'm not changing anything else. Okay. So there's my new matrix. We're almost done. I want a leading one. So the second column is done. I've done the first 2 columns. We just got to finish off in the third column. I want a 1 here. So again, let's just multiply the last row by -1. I just change the signs. I get 1, -2. And now to make this into a leading 1, I just need zeros above it. So what I'm going to do, maybe I'll just do this sort of in one step to save my